So welcome everybody to Rocket Community Sync number 25. I think it's going to be the last one before Christmas, right? Great. So, Merry Christmas, everyone. From my side, I have two demos for you. The first one is a feature on the MVP. Okay. So the first one is a feature on the dash wait option for rocket status. As of now, you could only specify dash wait equals true or false, which would block indefinitely on your command line. And it was up to the caller to handle any timeouts. Additionally, we needed especially for the container runtime interface, we needed another wait subcommand or wait option. And more concretely, dash wait ready command line option, which waits until the application is ready itself. So as a replacement for system denotification, so to say. I prepared a demo for this one. So let me share my screen. So hopefully everybody can see the terminal. Is it okay? Okay, great. So in I have two terminals here. In one terminal, I'm starting simply Rocket with a very simple shell script, which just always echoes something and sleeps for 500 milliseconds, and then does so in an infinite loop. And then you can, in another terminal, determine the UUID of the running pod above. And then simply you can specify rocket status and now dash wait, in this case, 3 seconds for the pod UUID. And then after 3 seconds, this one should bail out, telling you that the deadline is exceeded. So what happens if within this time frame the pod actually exits successfully? Well, let's see. We again wait 3 seconds, stop the above container, and then down there you see the result of the blocking wait. This time the deadline was not exceeded, but rather we got the state of the exited container as one would accept. So I think this will make it a little easier on one side for the CRI and also for other orchestrators to integrate. We also still do understand the true and false knobs on dash wait, which will retain the old semantics of blocking indefinitely. So it's like a hybrid setting. You can either specify a timeout or a Boolean value for this one. I then set up a demo for the dash wait ready, but it works exactly the same way. You can either specify true or false for wait ready or a timeout. Do you have any questions regarding this feature? No questions. Great. Okay, so let's move on to the second demo then.
So, sorry.
Okay.
This was for the CRI part, right? For properly waiting for the pod to become ready and to finish without too many X and yes, in a working way, without races.
Yes, exactly. So previously we have been polling for a magic file to appear. Now you can just simply invoke rocket status, wait ready, and with the given timeout. And once that one returns within the given timeout, with an exit code 0, you can be sure that you can add and remove applications to the sandbox. So that was the concrete use case for the CRI, but also we included the timeout for the good old dash wait parameter, if anybody has ever used this one.
Okay, and Iwan, do you think it's enough, or are we missing some other details from there?
It seems like it should be the right way to prevent race conditions between waiting for something to stop and actually removing it, or conversely waiting for something to run and actually returning that it's running, as long as its implementation guarantees that. And I think that's the intent of it. So worst case, we can modify it to be correct if it is not. But no, I think it is correct.
Yeah, this rocket status wait wait ready considers the whole pod. So the wait ready is actually waiting for the sandbox to become ready, not for a application inside.
Right, I understand that.
Okay, great. Okay, so I just want to make it clear that this is not, this is just for the pod as a whole. Okay, so proceed. Okay, great. So second demo. I think it was also Yuan who reported, of course, validly that currently the sandbox retains the semantics that we had in the previous rockets, immutable pods. Namely, if one app quits, the whole pod goes down. So that's how Rocket currently is architected. And for the sandbox, this really doesn't make sense. It should be up to higher orchestration layers to control whether the whole sandbox has to be stopped or not, given an application quit either successfully or not successfully. So currently, this feature, the app sandbox feature, quits pretty prematurely if an application fails. But I have a pull request standing. There are just some functional tests missing. But essentially, it already works where we actually implement the wanted semantics that the sandbox does not quit. And I prepared a second demo for this one. Again, 2 terminals. In the above terminal, I'm starting a sandbox using --debug, so there is a little bit more output to it. And in the lower terminal, I will add some applications to it. So first of all, we determine the running pod, the running sandbox. And I'm just adding the application here. Similarly to the demo before, this is just a busy box which loops indefinitely, spitting out hello messages. Then we are adding another application, this time a faulty application, which should immediately quit because we are trying to invoke a command named fail, which does not exist in that container. So one doesn't really make sense. And we add a third application where we actually have a valid command, but that command actually exits. This case, I just exit with exit code 23. Don't ask me why I picked 23, just for demo purposes. So in the third application, we find a valid command, but just with an invalid exit code other than 0. So let's do all of them. We have now the 3 apps created inside the empty sandbox. And we start the first application, and that one is outputting in the above terminal the hello messages as expected. So it's not faulty, it's running successfully. Okay, sorry, I'm still having the demo down here. And then we are starting the second application, and you should see up there, BinSH fail not found. So that one failed, but as you see, the sandbox is still running. So the first application still outputs the hello messages. And then the third app just exited, so it didn't produce any output with exit code 23. But as you see, the sandbox is still running. So let's see the status of those apps in the sandbox. So the first app is still running, state is running, as you would expect. You can query this with Rocket App Status. Then for the second app, it's exited with exit code 127. That's from the shell. And then the third app, as expected, exited with exit code 23 as we envisioned to do so. And yeah, as you see above, the sandbox still runs and runs and runs happily. The same goes true also for restarting applications manually. This one I didn't put up in the demo anymore. But if you start and stop applications, obviously, as it has done before, the sandbox just keeps running. So that's all from my side. Second demo. And questions for this functionality. Also asking you on functionality that you would expect.
Oh, yes, that also seems as I would expect. Thank you very much.
Great. So, just add some more tests around it. We have a small sandbox smoke test currently in Rocket. And now I have some more ideas for use cases, namely exactly those that I just demoed, starting, stopping faulty apps and expecting the sandbox still to be running. Okay.
Do you think that we're going to want to port this over to, so for those of you who are missing the context, this is because the current Rocket setup, Rocket sort of has two execution modes, one of which is the sort of traditional Rocket mode, and the other is this sandbox where you can add and remove applications as you like without killing the actual pod. And this is super useful. It's needed for CRI for Kubernetes, but it's a useful concept in general. And so in any case, the context is that in the traditional Rocket mode, if any application ever exited with a non-zero exit code, we immediately killed the pod. Do you think we're ever going to want to bring this behavior from the sandbox into the non-sandbox mode, or do you think we're pretty much just going to always leave this in sandbox?
I think that the reason that we might want to bring it to non-sandbox is if we sort of merged the two modes and made it so that the regular mode of execution is initialize a pod with this set of applications, and then later we can potentially mutate it to stop a subset of those applications, or to stop all of them and add more. But if you can't add additional applications, it seems relatively useless to actually leave the sandbox running when it's this thing that can't be mutated further. It can't have anything added to it. It can't actually do anything.
Yeah, I don't actually know how much work it would be to merge, to make all pods mutable, right? Even if you don't have the sandbox.
The lifetime thing is distinctly different semantics, so you would have to provide some sort of toggle between different lifetime semantics for the sandbox that surrounds it, pretty much.
Yeah, and I don't think we could. It would be hard to change after you started a pod, but maybe, I don't know.
Also, from an implementation standpoint, we have to do quite some things to persuade systemd either to prematurely exit or actually prematurely not to exit if they're absent.
Sure. Okay.
That the whole systemd dependency graph setup is quite distinct in both cases. Envision it quite difficult to merge them completely, but there are always ways.
Another question that we had today regarding more the kubelet and the Rocketlet itself. Whenever an application is stopped or is failed, and the kubelet wants to restart it, does it actually restart the same instance of the application, or does it proceed to remove the current one, add one which contains the same image, and start it?
It creates a new application which happens to have a similar name, and it is only coincidentally that it has the exact same config. We do not have to care that it is the same application. It will just send the exact same request other than having a attempt number incremented by 1. And because of that, we identify our applications uniquely by name plus attempt number. If you look at the naming scheme, it's like 0-nginx, 1-nginx, whatever, and that is the attempt number for that application from the kubelet. All previous attempt versions might be removed eventually, but you'll typically have the last 3 or 4 attempts in existence at the same time. To us, applications proceed from non-existent to created to running to exited to removed, and they never go backwards. They never reuse existing states from the past.
Okay. So currently, we also support reusing the existing state. You can just start and stop existing applications instead of having the necessity to add or stop, add, remove the old one, right? So that's something I was tackling just because we exposed this functionality. But if it's just removing old applications and adding new ones and starting the new ones, even if they are pretty much the same, this also works, obviously, with the current sandbox. So I guess we support both modes of operation. Okay.
Actually, if I may interrupt real quickly, Brian and GW Haley, I don't think I've actually met you guys before. Would you mind introducing yourselves?
Exactly.
Howdy, I'm an interested Rocket user. And I've been following Rocket since the initial blog post came out. A huge fan of the security model and the ACI model, RIP. I was a fan of the sort of multi-layered image manifest design, which is going away with OCI, I believe. I'm also interested in Nomad and have been working to sort of prove that integration with Nomad, and I'll be adding in some fixes to that driver Nomad. I'm also a little concerned about Rocket's how much longer it's going to be around. I guess some rumors coming out of reInvent sounded like it may not have a real long lifespan. And so I'm hoping that it continues to give Docker a run for its money. And so I'm kind of here showing support and also making sure that it's still going to be viable as we go to put it into use in our new production environment. So just for an updates, Rocket as it is currently staying. So it will still exist because we use it at the base of CoreOS, the distribution for several things. It will just gain a couple more feature and probably some kind of wrapper in front of it, which at the moment is Rocketlet, in order to talk natively the CRI protocol, so the CRI specification. But under the hood, the low-level component would be still Rocket itself. Good to know. Thank you.
Okay. Hi, Graham Whaley. So I work for Intel, so me and a couple of guys are taking over the KVM work under Rocket, so the VM runtimes. So particularly we're moving towards using the same optimized QEMU that we use in the Docker runtime we have for Flink containers. So we filed a couple of PRs this week, hope to get another one in tomorrow, and then we'll sort of try and fix up a lot of the issues we're seeing at the moment, or some of the pending issues in the GitHub, and migrate the QEMU towards a more optimized QEMU. And then we'll investigate what we're going to call it, stage 3 or 4 of the small OS that runs inside the KVM. So the actual kernel inside KVM, we have a different version. There's the CoreOS that we currently use on QEMU, and then we have a clear Linux-based one. So I don't see us necessarily deprecating the CoreOS version, but I think we should at least benchmark the two and then possibly have clear Linux as the other option for the small OS that launches the payloads. So that's currently my pretty much full-time work, is working on KVM runtimes. And I've met a couple of you guys, I think at LinuxCon. So,
Nice to meet you. Nice to have you on board. Okay, so next item is John, but he's not around, so maybe you can take over.
So I'm taking over also because I will have to leave shortly. A status update from John and me and the rest of the team. We put together a bit of road mapping and a status update for the last quarter of 2016 and the first quarter of 2017. And basically the blog post that we published yesterday, so it's public since some hours, contains what is the current status of what we did for the CRI at the low level, so this pod sandbox that it was partly demoed before, and the ongoing work on the attachment part that I demoed some syncs ago and is close to land in its experimental form. So both of them will go through a couple of stabilization cycles. And then there is more road mapping and more future plan for OCI in general, which we started with the distribution points PR, distribution points concept in general, and will be followed by more store reworking, more store changes. And this is basically all public news, but it's just put all together in a single place, which is easy to to read and get together. From my side, in the last few days, except for this road bumping stuff, I was working still on the attaching part, which was very rough so far. Now it's getting much better. And especially I was implementing the cleanly exiting, so not abrupting everything when there was an error, but providing a user with a clean way of detaching and also cleanly stopping all the attached client when an application goes away. And this is in the current PR. I think it will still take a couple of review cycle, but it's getting better and better. There will be, even when merged, there will be still some low-level details to be fixed, like all the TTY setting up, which is currently not done. And it will also be followed by more custom logging for the CRI part, which is kind of a draft in the current code and needs a better integration later. And this is the update from my side.
Cool. And if you're talking, Casey, you're muted.
I'm still muted. How about now? Oh,
yeah,
thank you. Sergey got me. The context in that, of course, is that Rocket does not have attach, which is a thing that Kubernetes people seem to really like. I guess people like watching their processes. So we have a TTY in between that is shunt. So super interesting in the KVM case. I think it should not affect anything, but as always, these sorts of interactive things are super exciting when it's on KVM time.
Yeah, the most notable Kubernetes use case that supports, if you're familiar with their workflow, is the kubectl run-it, which has attached semantics instead of exec semantics. Anyways, to give a quick update on the integration of Rocket into Kubernetes Mark II Rocketlet, over the last couple of weeks, I improved the testing. So we now have integration testing between Rocketlet and Rocket. I've also been working on getting the integration testing between Kubernetes and Rocketlet to work, and that has resulted in a myriad of bug reports and such, which is it's great that we're getting good progress there. The most notable things there are that Privileged had totally broken semantics before and now has slightly wrong semantics, but good enough. Namely, privileged semantics are now at a pod level, not an application level for path masking, but are at an application level for capabilities and so on. So it works very well for the case of an entirely privileged pod. It works slightly less well for a mixed pod, and that your paths will be unmasked for every application. That is something I will also be filing additional issues about. I also caught a small number of race conditions due to just how quickly the Rocketlet expects to operate, and Rocket not being perfectly crisp on semantics between things, which is what that wait things fixes, and that's awesome. And there are a couple other bugs. If anyone would like to join in on this, you would be welcome to. I will provide a couple of quick links here, but just wanted to give a quick status update there. If anyone has questions, that's also welcome.
I think we can skip directly to the question that you added later because it's related to this one, I guess. If we should split out artifacts when building Rocket from our CRI, right? I guess it was in the context of reusing them from the Rocketlet CI.
No, it actually was not, but that is a good use case for it. It's just something that I've wanted several times myself when I'm thinking, oh, I want to git bisect this. I guess I'll have to build every revision as I go. That's going to take another 20 minutes on top of every bisect step. Or, oh, it would be really cool if I could check this on current master. I guess time to build it again. And I figured it could be a quick time saver for some people. And then the most notable use case this fixes for me is I would be ashamed to admit the number of times I've SCP'd Rocket from my laptop to a GCE or AWS instance and had it not run because my C flags include march native on my local machine, which results in a Rocket binary that only runs on my laptop, not on any other machine pretty much. So it would be convenient to have that.
Okay, I think we touched into this topic already once before, and it was when we were doing the OpenStack integration, which more or less had the same concern. My 2 cents is that I'm not super happy with that because I don't want a user to start relying on those artifacts, which are coming from kind of untrusted infrastructure, let's say, or at least not something that is supposed to produce production binaries. And on the other hand, this is like not how you should be pulling out Rocket binaries. So I don't expect those to be signed in any way. On the other hand, I see some use for it when integrating other CIs that need to have Rocket, or at least they need to test some new features in Rocket or recent Rocket version. This is one use case, so that's why I was thinking about the Rocketlet, for which it may make sense not to rebuild every time Rocket as part of the Rocketlet to cut a bit down the testing time. That's probably one use case. And the other one that you mentioned is like in order to bisect. In that case, we also need to store basically all the past artifacts that we produce. That's more or less, that's just like, from my point of view, I'm not super happy with having that, or at least not advertising it too much. But having that for testing purposes, it may be fine. I don't know, like it shouldn't be an hard task. I currently don't have access to that account, but it can be done. I'm just waiting for that. And I guess we can just set up another S3 bucket and push the artifacts for successful build to there. We are already building nightly, no, twice a day. So that wouldn't be a big issue, I guess. That's it.
I was actually thinking for Rocketlet CI, for whatever reason, it didn't occur to me to even do master. I was figuring I would just have a release number and say, this is the supported release for Rocketlet. This is what we will integ test against. But it would be more useful if it could be against latest master to catch regressions there as well.
I see. Yeah. So what's the consensus here? I guess we can do that. There are some use cases, so probably we should, and it's not too hard. So once again, so we probably should. I'm just not too sure how to position that, but it's. I think it's doable. Let's do it, right?
Agreed. Yeah, we can make it in a way not super public, not super documented, just for our purposes and for our testing purposes. So as long as it's this way, I'm fine with that solution. Okay. Next question. Also
and while we're talking about CI, I threw on another one. We had a report recently that Rocket runs slower, and I have actually noticed that qualitatively myself that it's gotten a little slower. Recently, I compared it to the 1.0 release just out of curiosity for how it's changed over the year, and launch times for me went from something like 0.5 seconds to 0.7 or 0.8 seconds using secure options on disk and very small images and all that. My question is basically, should we perhaps try to nip this in the bud by having a CI system that does benchmarks on each release and notifies you if it gets significantly slower, and ideally does a graph like, are we fast yet, or something like that, so that we can see where it's gotten slower in the past. And then if it gets slower for good reasons, like we're adding a new feature where it needs to be slower, that's fine, we can accept it, as long as we are willingly accepting that trade-off, not just implicitly coming back later and saying, oh, it got slower, I wonder why.
I think it is valuable in the general sense, or at least I like the one that I've seen from Mozilla, Rust, and so from Firefox, Rust, and all the other Mozilla projects. One small concern or doubts that I have on that is that we also rely on other tools. So we rely, for example, on systemd, and we rely on Runc probably soon, and perhaps other utilities. In that case, we will basically be starting to track down regression, performance regression in other tools. I don't think we have that much bandwidth to basically start doing that. So I'm okay with having a graph and tracking down performances, and that's easy for us to see, okay, this PR introduced a big regression in performance, so there probably is an issue. But in general, I feel that it's gonna produce more bad values than positive values, in the sense that that graph will probably keep going up release after release, because we are implementing our new features, and then all the projects that we have are also implementing new feature. I think none of those are mostly focused on performance, so I don't have any performance graph from systemd, for example. I don't know about QEMU and RunC, but I guess it's more or less in the same case. Well, I know that those graphs, they apply perfectly for projects that are like self-contained and you manage completely. In the Rocket case, I'm a bit more skeptical about what we can get once we have those values. So it's nice to have those values, of course. I'm just wondering like what we do then when we have those values. I mean, if I see that bumping systemd CoreOS alpha introduce a performance regression, that's nice to know, but I probably will not have time to track down that, or at least it's not enough high priority. So that's my concern.
Probably still useful to have though.
Yeah, I think we can all agree it's useful. It's just a prioritization thing of, is it useful enough that we want to spend time on it now?
I don't know, perhaps we can like try to come up with a plan to provide those data. So setting it up in the CI environment shouldn't be a big deal. But then we should come up with a better plan on like what to do, what is actionable on that. So of course we care about performance, but it's not one of our top priority, at least at the moment, given that we are like in a high flux. So I cannot guarantee anything on that side, unfortunately.
From my side also sounds good, given that we also have some performance tests checked into the Rocket upstream code base, which we actually, I think, currently do not execute in an automated fashion, right? So
yeah, we have a benchmark tool, but I don't think we run it.
Yeah, exactly.
I also think there have been some questions about its correctness a couple times.
Okay. Okay. Nevertheless, we have something. We can do simple things like do a percentile of starting some container in a row. I don't have a big problem with that one either. Yeah, but I share the same concerns. Currently, we have a pretty tight roadmap regarding CRI and LCI. So as I see in the round here, everybody is concentrating on these topics right now. Okay.
Out of curiosity, Yuan, do you have any, like, what's the nature of these performance slowdowns? Is it worse for larger images? Is it, I mean, yeah, because I've heard about it as well. And oftentimes the simple solution is, yeah, okay, just, insecure options on disk.
Right, but even with that, there's noticeable slowdown, and I don't know the answer for what causes it. I have not done the necessary bisecting or the necessary flame graphs or whatever other things I could be doing. I've just observed it.
Yeah, no worries. Just curious if you'd heard anything more about it.
I also worry that if it gets too bad, we might end up in a state where we occasionally say, okay, this week we're just going to spend a week hunting down all performance issues and fixing them, and then we'll do that again next year, and then the year after that. And it's much more sustainable if it's on a per PR basis that you identify performance things versus doing it periodically.
Yeah, for sure, that makes sense.
But I don't think it's bad enough yet that we will be doing it periodically for a bit yet anyways.
Yeah, that's a reasonable point in favor of tracking down per PR those data, so you may be right.
Okay, so unless there are no more objections or any other questions in the round, we still have theoretically 20 minutes to go. But I have no problem that we all quit a little earlier. So unless nobody else has another topic, please speak out loudly now. Okay, I guess not. So thank you very much, everybody, for the sync. And yeah, unless we don't see each other, have a great vacation. Happy New Year from the Rocket team.
It's nice to meet you all. Thanks for coming in.
Yes. Thank you for joining us.
Thanks for all the good work, guys. I appreciate it.
Yeah, looking forward to see you again in the next sync next year. Bye-bye.
See you all next year.